In this project, we have set up a database, Apache Cassandra, and we've filled it with comments from the web forum Reddit. Then we've set up a cluster computing framework, Apache Spark, and then a web server running a node that sends jobs to Spark as pre-configured queries. And to present the results, we then have a web interface that allows browsing the Reddit comments. And the purpose of this is to demonstrate a distributed architecture for performing complex queries with good performance. Apache Cassandra is a distributed column-based database management system. It's easy to set up a cluster, it's many prominent users including Netflix, Apple, Instagram, and we're using it with repetition level 3, meaning we have all the same data on all 3 computers for maximum performance. So now we have started Cassandra and connected 2 other nodes, creating a database cluster. Let's go into the CQL shell and do some simple queries. First of all, just want to see what kind of attributes we have. Notice the different colors here. They determine how we have partitioned our table. So let's search for something simple. There's some scores here. They are retrieved very quickly, even though we have many gigabytes of comments. But the next queries don't work as well, and that's because we can't filter based on columns of lower order without also filtering on the columns of higher order. And these kinds of limitations of Cassandra is why we need to continue and use Spark.
Apache Spark is a distributed framework for performing calculations on big data sets. You can use programming languages such as Scala, Java or Python to program in Spark and compile it for a Java virtual machine. The most important functionality in our implementation is that Spark can be run as a cluster, with applications being uploaded and ran on all the machines in the cluster. We will now start a Spark master on this machine. You can now see that there are currently no slaves connected, so we will now start a slave on this machine using the start slave command. And if we now update the master interface, we can now see that there is a slave connected, and if we update it again, we have now connected 2 additional machines to the cluster. Since we wanted to create a web page for our implementation, we needed to be able to send queries to Spark over HTTP. To do that, we needed a Spark Jobserver. A Spark Jobserver is a server application that runs locally on a machine that is connected to the Spark cluster. The Jobserver will create a context that then runs on the actual cluster. The Jobserver will receive jobs whose results can later be fetched via the REST API. We will now start the Spark Jobserver using the start server command. And if we now update the master interface, we can see that we have an application running on 10 cores with 7 GB of memory per node.
Now I'm going to show you the web server, which is used to send requests to the Spark Jobserver's RESTful API, as well as displaying data from the dataset on a web page. So we start off on the front page, where we want to display all the subreddits in the dataset. So we connect to the Cassandra cluster consisting of these 3 nodes. Then we define a query where we select all the subreddits from the comments table of the Reddit keyspace. And then we execute the query in the Cassandra cluster. This is going to take us to the next page where we want to display all the threads that are under a specific subreddit. So here on the second page, instead of connecting to the Cassandra cluster, we send a post request to the Spark cluster, where we define which app to use, and this app is going to consist of all the jobs that we have written, and we're going to define which job to run and in which context to run it, and this context is going to be the one that we just created when we created the server. So here's an example of a job that is defined on the job server. We start off with a base query that selects all the links, which is basically threads. Then we append the subreddit to the query, which is passed as a parameter from the web server. Then we let Spark execute this query with Spark SQL on the Cassandra database. We map the values and we return them. So let's start the web server to show you what it looks like. Again, on the front page, we want to display all the subreddits that are in the dataset. We can search for a specific subreddit, and when we click on a link, we will submit a job to the job server, which any free worker can execute. So now when we click a link, the get threads job will appear on the job server, and when the job is complete, The results will be returned to the web server and displayed on the web page. When we click on a thread, we submit the next job, which is to get all the comments for the thread. So the get comments job will be submitted to the job server. Any free worker will execute the job, and the results are returned to the web server and displayed on the web page.
So, what have we learned? Well, Apache Cassandra is a very powerful but very specialized database management system. It has its limits, such as only being able to optimize a table for one type of query, really. And it's very fast, but only when its limitations are taken into consideration. So an additional framework for computation is needed. Now, connecting Apache Spark to Apache Cassandra and accessing it through a REST API was not very straightforward. It required a lot of custom configuration and a lot of headaches, and perhaps this was not really suited for our use case. Running complex queries on Apache Spark on a cluster and combining that with Apache Cassandra on a cluster resulted in a 62% performance increase compared to running it on a single machine. And the performance is quite good, and the increase while running on a cluster is notable, although it's not huge. We didn't manage to get it down to sub-second levels. To get better performance, that would require many more cluster nodes. Or perhaps there are other frameworks than Spark more suitable for presenting this kind of data.